Hello, this is a video about the fundamentals of plotting in R. We're going to spend a bit of time talking about the graphics devices, the various graphics devices in R. So these are the kind of the canvas that you draw plots on. And when you call something like the plot function in R, basically what it does is it opens a graphics device and draws upon it. And then we're going to talk a little bit in detail about the plot function and then various other related functions like points, lines, text, mtext, and different ways to modify your plots via graphical parameters. All right, so let me fire up R here. And let me make the right side a little bigger. Okay, so when we call a function like plot, what actually happens? So if I run this piece of code, it pulls up this little window here and draws some points on it. So the window here, you can see at the top, it's called R graphics device 2 active. So we're going to talk about what all that means. But this is like another window, and if you see the program it's using the R program instead of Emacs here. So this is kind of a separate window for drawing plots. If you're in RStudio, RStudio actually has its own built-in graphics device. Usually it would show up in the bottom right corner, but you can also pop that out and get something like this in RStudio as well. Okay, so all R plots are drawn on what are called graphics devices. So to read a little bit about them, I'm going to open up the documentation for a function called dev.new. And in this documentation, there are several different functions that are documented. dev.cur, dev. All the dev. Family of functions. So dev is short for device. And the description says these functions provide control over multiple graphics devices. All right, so let's see if we can find anything here. Okay, so let's go back up to here. So dev.cur is going to return which graphics device is active. Dev.list will list them all. Dev.next and previous allow you to cycle between them to select which one you want to be active. Dev.off closes. Dev.set, I'm not sure. What does dev.set do? Dev.set makes the specified device the active device. I see. So it's a way of picking which one you want to make active. Dev.new opens a new one. And graphics.off closes all of them. All right. So if I call dev.new, I'm skipping this line here. This just opens a graphics device and doesn't call anything, doesn't plot anything on it. If you were to call the plot function, if there's no graphics device open, it opens one first and then draws on it. So there are various different types of graphics devices. I'm working in Linux, and the default graphics device is called X11. So let's actually look at the documentation for that. Let's see. On Unix alikes, Linux is a Unix alike. X11 starts a graphics device driver for the X Window system. This can only be done on machines accounts that have access to an X server. So what this does is this opens an X11 graphics device. Let's see. Is there a list of the various devices? Let's see if I can get that with... here we go. So there are lots of different types of graphics devices. What dev.new does is it opens the default graphics device. And on my system, it's called X11. If you're on Windows, it's called Windows. If you're on Mac, it's called Quartz. That's the one at the bottom here. But you can see there's lots of different ones. PDF opens a PDF graphics device. What this is going to do is it's going to open up an invisible graphics device, and then you call various plotting functions to draw on it, and then you do dev.off to close it, which writes it to a file. We'll see an example of that in a second. But in addition to creating PDFs, you can create postscripts, bitmaps, pictex if you've ever worked with that. That's kind of a rare one. SVGs for vector graphics, PNGs for images, JPEGs, bitmaps, TIFFs, so on. So there's lots of these different graphics devices. Dev.new will open up your default one. On my system, it happens to be X11. When you open up a graphics device, you can specify various different parameters. So if we go to, let's look again at dev.new. Dev.new has a ... So these are arguments that are passed to the selected device. And my default is X11. And for X11, you can see you can specify the width, the height, lots of different things, point size, gamma, the background, if you want something other than white, fonts, family, XPOS, YPOS. This tells you where on your screen you want it to appear. So lots of different things you can specify. So I encourage you to read through the documentation on this. So for example, if I do width equals 7, height equals 7, XPOS equals 1000, YPOS equals 200, that's going to move it over to the right side here. As you remember before, it opened it up on the left. So this is, I changed the X position by 1000 and the Y position by 200. Now if you do dev.list, it'll list all the open ones. Right now there's only one open, but if I open another one, there's one there. Now I have two of them open. To close the current device, I do dev.off. That'll return the remaining ones, so there's still one open. And to close all of the devices, I do graphics.off. Now if I list them, it just says null. So you can use these dev.functions to open and close graphics devices. You can use it to switch between which one is active, so that the one that's active is the one that's going to get things drawn to it when you call functions like points and lines. You can also set default options for your graphics devices. So if I set the default options to be here, and I call it without options, it'll open it up over there where I want it to. I can reset them and then call it again. It'll reset it back to here. Turn them off. Make a new plot. So this is to show you that these graphics device options stay active even if you turn off all the graphics devices. So here I set them to be this, and then I turned off I closed all the graphics devices, and then I called a new plot, and it put it at position 1000 here. Now what we've seen so far, we can think of as interactive graphics devices. So these are graphics devices that get shown on the computer screen, and you can add to them and you'll see the changes appear on the graphics device. Now, like I showed you before in this devices documentation, if you want to look at those, you look at this documentation. There are lots of other ones, and most of the other ones are invisible graphics devices, meaning that when you open up the graphics device, nothing gets shown to your screen. But that doesn't mean nothing is happening. When you call various plotting functions, it will draw to that invisible graphics device. And then when you close it with dev.off, it will close that graphics device, and then it will save a file. So one of them is PDF. That's probably the one that I used most commonly. So let's look at the documentation for PDF. It's right here. The first argument is a file name. The default is, let's see. This is kind of, we have to look at this. So there's an argument called oneFile that says, I've never read this before. oneFile, logical. If true, the default allow multiple figures in one file. If false, generate a file with name containing the page number for each page. I see. This allows you to do multiple page PDFs. But the default is true. So the default for the file argument is if true, so this is active. The default file name is rplots.pdf. Then you can specify a width, a height. So usually I overwrite I specify a file name because I want to save it for a specific file name. But I also specify the width and height, and then you can change various other things as well. Use dingbats. What is that? Should small circles be rendered via the dingbats font? All right, we're going to have to check that out. Okay. So here's how the code works. I'm going to open up the PDF graphics device. And if I were to call dev.cur, it tells me that the PDF graphics device is open. And then I call plot, nothing happens. So there's no, this is an old one. Let me actually start over so I can show you. All right, now there's no devices open. I call PDF, dev.cur, okay. I do plot, and nothing has happened, so I don't have any graphics devices open. I do have one open, but it's not visible, pardon. And then I call dev.off, it will close that PDF device. And now there's a PDF saved on my computer. So if I go over here, I can actually open it in Emacs. And that's the file. So you can see over here, it has opened up plot1.pdf. I don't know why this blinks, but it does. And it drew a file. Okay, so this is a PDF file that I'm just viewing inside of Emacs. I can also show you, I can open it up. With my PDF viewer. This is my PDF viewer on my system. So these are the same file. Okay, you can also do JPEGs. So PDF, the units are inches. For the image ones, the units are usually something like pixels. So if I do JPEG, I have, JPEG dev.cur. I have a JPEG device open. Draw a plot, close it, and now I have here's my JPEG plot. Okay, so these are just two of the many graphics devices, PDF and JPEG, but using them, you always use it like this. And if you're making figures for a paper or document, I recommend using these graphics devices directly. Because if you're just like writing code to make files and then resizing them manually by pointing and clicking on them and then saving them, that's really hard to reproduce. If I instead have code like this, where I specify the width and the height in the code, if I need to change something about the plot, like I want to make it wider, it's really easy to do that programmatically. So I would just change this to 9 and rerun the code, and now I have the plot of the right size. So I really recommend using these graphics devices to create plots for documents that you're making. Now, if we're not creating a document and we're just messing around in R doing some exploratory data analyses. We don't really need to save anything, and usually we don't really think very much about the graphics device. So you should know what a graphics device is and what it's doing, but most of the time you really don't think about it. And most of the time you just call a plotting function like plot or hist or I don't know, various other ones, contour, and it'll draw it on the screen and you can visualize data that way. So what actually happens when you call one of these functions is that if no graphics device is open, it will open one and draw on it. It'll open the default one. If there is one open, it will just draw on the current active graphics device. So we're going to look at the plotting functions and some of the options in them. I just created a kind of a simple example here. So I created a function called circle points. What this function does is it generates some data that we're going to plot. And the way it generates the data is it creates points along the exterior of a circle and adds some noise to them so they're not just on a circle. So you can look at the source code. It's not too complicated. I create a bunch of angles and then the x values and the y values, and then return them. Okay, so run that function. I'm going to call it with the default arguments, and now I have x1 and x2. And if I do plot, it will open up the plot. So here's my circle points. Now in this plot, we have control over basically everything here. We can change the style of the points, the size, the color. We can decide whether we want a box around the plot. We can decide that we don't want axes or we want to do different types of axes. We can even change the fonts, the margins, all kinds of things. So what we're going to do first is just take a look at the documentation for the plot function. So here is the default plot function. You can see it's designed to draw a scatter plot with decorations, such as axes and titles in the active graphics window. Okay, so you can see that there's a lot of options listed. We'll go through some of them. And then there's also, you can see a lot of options not listed through this ... and we'll look at those as well. Okay, so the first two arguments are the x and y values for the scatter plot. So that you've probably used before. We just did that example. The second argument is type. The default is P. Let me make this bigger. The default is P for points. But you can also do a line plot if you set it to L. You could do both points and lines if you set it to B. We can do C for empty points joined by lines. O for overplotted points and lines. S for stair steps. H for histograms. And N for nothing. Why would you want to do nothing? We'll look at some examples later on. This is actually can be kind of useful for programmatic plots. A lot of times if you're, for example, if you have a loop where you add points to a plot in a loop, oftentimes you'll want to set up an empty plot with nothing in it and then loop over the various points you want to add and add them one at a time. So this can be useful. This type equals n. You can set the limits of the x and the y axes. You can specify whether you want things plotted on the log scale. So if you say log equals string x, it will plot the x-axis on the log scale. Main is a title. Subtitle. X labels. This is so if you want to say the x-axis is meters, you can say xlab equals meters. An is tells you whether you want default annotation, which means the title and the x and y axis labels. Axes tells you whether or not you want axes drawn on the plot. Frame plot. Oh, do you want a box? Panel first. Well, you can read through these few. The other one is aspect ratio. This can be useful if you want to make sure the axes are square. And then there's other ones as well. Now there's also ... Why don't we come back to this? So you can specify a whole bunch of other things, and we'll come back to this in a second. Okay. I want to add C. Okay, so that's x1, x2. So this is the default. If I do type equals L, it connects them with lines. Type equals B, it does points and lines, and the lines are not connected. Type equals C, just does the lines, unconnected lines. O, this one I like, I use this quite a bit, puts points, connects the lines and put points over them. And type equals N gives you an empty plot. The useful thing about this is it set up the axes so that all the points would fit if you plotted them, but doesn't plot the points. All right, and then you can change the limits of the axes. So xlim minus 2 to 2 does that. If you do x and y, you get that. You can add labels. Let me make this look nicer. Horizontal position, vertical position. You can change the plotting symbol so that you do that with PCH. And this is a good opportunity for us to look at par, because PCH wasn't documented in the plot. So let's look at par. So these are additional. Par is another function that sets default values for various graphical parameters. What we're going to use it for right now is because it documents other things you can add in the plot function. So you can see, so first thing I'm going to do is just scroll through all the values, and then we'll look at a few of them. All right, I'm just going to scroll, just so you can see that there's a lot of things that you can change. There's stuff about fonts. I don't even know what all of these do, to be honest. Line widths, margins, outer margins. Oh, geez, SMO. Oh, not implemented. Okay, so there's a lot of stuff in here. So I recommend that you read through these things. I guarantee you'll find something. I mean, I'm looking at this and seeing things I don't know about. I guarantee you'll find something new. So the things I'll show you that are documented here are your BG is a background color. CEX is used to change the size of how big things are that get plotted, text and symbols. You can specify the size. So CEX, when you see CEX, think size. So CEX.axis is how big to make the axis annotation. Labels. Main, this is for the title, subtitle. Colors, you'll use a lot. So this changes the colors of the plotting symbols. Axis colors, label colors, title colors. What else? Family. You can do serif fonts. You can do monospaced fonts, sans serif fonts. That's the default. Foreground color. Font. So font means whether you want plain text, bold, italic, or bold italic. what else do we use? Oh, line width. So when you plot lines, you can make it narrower or wider. Margin we'll use later. MF col, MF row we'll use later. Outer margin, PCH. So this is the plotting symbol. So it accepts a number. Let's see, either an integer specifying the symbol or a single character. Points will tell you the possible values. You can also specify a character, and it will use that character. Okay, that's enough of that. Let's see this in action. So this is the default. Unfilled circles. If you change it to 2, you get triangles. If you put in a vector, it will recycle. So this is recycling between circles and triangles. And then you can do 0 through 16. So this is the first one. 0 is a square, circle, triangle. You can see there's a bunch of different ones. Okay. You can change the sizes with CEX. And these are relative to 1. So 1 is the default. If you do 2, it's twice as big. If you do 0.7, it's 30% smaller than default. Let's see. There's a function called points. So points is different from plot because points will not open a new graphics device. So if I were to close, so let me close this one and let me call points. Let's see. It did open one actually, but it gives an error. So plot.new has not been called yet, which means it didn't have a graphics device to draw on. And let me see if I do it twice, what happens? No. So it does open a graphics device, but it doesn't set up the figure to plot on. That's what it does. So plot actually does a few things. It does opens the graphics device, it sets up the figure, and then it draws points on it. So if I want to use points, I have to call plot first. Okay, there's my plot. Here I'm going to generate some new points, and then I'm going to draw them with points. That drew some triangles. Generate some new ones, draw some new ones, generate some new ones, draw some new ones. Okay, so points is used to add points to the plot. Likewise, there's one called lines. Let me make this nicer. Lines adds lines to the plot. So I'm going to set this up by drawing a plot with type equals L. And what I'm doing here, to change the code a little bit, I'm adding the first point to the end so that it closes the loop. If I generate new ones, I can draw it like this. Here again, I'm adding the last one to the end. Here I'm making the color different. Okay, so lines draws lines. And then text draws text. So if I make a new plot, this is useful if you want to sort of annotate the plotting symbol somehow, or just use text as the plotting symbol. So if I want to put a letter next to each plot, next to each point, I can do, so the syntax here is X position, Y position, and then the text that you want to add. Here I'm using the same X position, but I'm shifting the Y position by 0.1 downwards. So that will draw a letter below it. I could do numbers, I could do whatever. So text adds text to the plot. mText, this adds text to the margins. I like using this for titles because it gives me more control over where to put it. So if I do make a new plot, if I do, so the syntax is which text you want to add. So this is actually slightly confusing because text has the position first and then the text. mText has the text first and then the position. And for the position, you specify which side. So the plots in R have 4 sides. And they're numbered 1 at the bottom, 2 at the left, 3 at the top, 4 on the right side. So if I say side equals 3, it will do it at the top. And if I say line equals 0, it will do it just above the plotting region. So you can see that. And if I want to do a new one on the same side but higher up, I change line to 1.5. Font equals 2. I think we'll do bold. And then CEX 1.5 will make it bigger. Okay. So that's how you use mtext to draw text on the outside of the plot. And then there's also other functions as well. So we've seen points, lines, text, and mtext, but there's also a function called polygon for drawing filled polygons. You can draw rectangles, you can draw line segments, you can draw lines using the slope intercept form, and you can draw errors, and I'm sure there's more of these as well. And there's still so much more that you can control in the plots. It's kind of impossible to make a video to show everything that you can do in plotting. It's the kind of thing where you have to kind of read the documentation, work on some projects, and just learn as you go. But I will show you a few more things. If you want to make a plot with no axes, you do axes equals false. So the default is to draw axes, but you can do that. If you want to plot with no labels on the axes, you do and equals false. So that will draw the axes but not add the x1, x2. Oftentimes, if I want to have really strong control over my plots, I will use axes equals false, and I'll draw the axes myself. So to draw axes yourself, use the axis function. And the first argument is which side you want to do. So if I do axis 1, it'll draw one at the bottom. And definitely look at the documentation, because there's a lot of stuff here that you can change as well. You can specify where you want the tick marks to go. A common thing is if you want to have tick marks at certain places but use different labels, you can draw the axes yourself. So this will just draw them at specific points separated by 0.1, but you can also change the labels. Actually, let's do one of those. X equals 1, at equals So this will draw tick marks at -1, 0, and 1, and the labels will be left, center, right. So this is really useful for things like categorical variables. Oh, and then box will draw the box around it. Okay, here's a pet peeve of mine though. If you look really closely at this plot, you can see that, so you can see the sequence of what happens. You draw the axis, you draw the other axis, and then you draw the box. And you can see what happens is where the axis was drawn, this line is ever so slightly thicker than this line and this line. See, this is a little bit thicker. Hopefully you can see that on your screen. If not, check it on your own screen. And this is just this is kind of the definition of a pet peeve. This does not matter at all, but this bothers me. So if I get really picky about my plots, I will draw the axes myself, but make sure to not draw this line before I add the box. Oh, by the way, this happens when you call plot as well. So if I just do plot x1, x2, it's the same thing. You can see it's slightly thicker there. Okay, so let me show you how to get rid of that by drawing the axes yourself. So there's a line width LWD argument for axis. If you set that to 0, it will not draw that horizontal line that you saw. But if you do want the ticks, you have to reset the line width for the ticks to be 1. So if we do this, it will draw the ticks but not the line. Same thing on the vertical axis. And then if I do box, you can see now it doesn't overplot that line. See, that looks so much better. Maybe you don't care. Okay, but that bothers me. All right, so when we looked for more graphical parameters, we looked at the documentation for the par function. As we were looking at that, we were just using it to see what other parameters you could change in the default plot. But par itself is a function, and the usage of par is to set default graphical parameters for all plots that you draw. So I encourage you to look at this thing and read through the documentation. The difference between setting a parameter in par versus setting it in plot is that if you set it in plot, it will only apply to the current plot that you're drawing. But if you set it in par, that'll become the default for all plots that you draw. So if I do, one of the ones that I use most often is MF row or MF call. So if I set MF row to 2, 2, what I'm telling it is that I want to set up a plot where it's a 2 by 2 array or matrix of plots. So if I do this, the first time I call plot, it's going to draw a plot in the top left corner. Second time, it does top right. Third time, bottom left. Fourth time, bottom right. So there's MF row and MF call. The difference is that if you do MF row, it'll draw them in row order. So it does this one, this one, this one, this one. If you set MF call 2, 2, it will still do a 2 by 2 array, but it'll do this one, then this one, then this one, then this one. And then if I call plot again, it will start over in the top left. And if I close it, if I close that graphics device and I call plot again, it will forget what I set for par. So when you set par, it applies to the current graphics device. But when you close it, it resets the parameters. Okay, so just to see an example of the kind of things you can change, we can set the color to gray. So this will apply to, I believe, the points in the box. The axis to magenta. The size, plotting symbol to 4. And I'm going to change the margins as well. So the margins, the default I think is 5, 4, 4, 1. And they're in order. So this is bottom, left, top, right. So if I set those, it'll open a graphics device with these default values set. And if I do plot x1, x2, it's going to apply those default values. So here you can actually see much closer or better that it actually drew a black line here, even though the rest of it is gray. For this next part, I want to try something a little bit different. You can see I have a exercise prompt as a comment here. Draw a clock with Hershey fonts. I'll show you what the Hershey fonts are in just a second. But you can see I have no code laid out here. So what I'm going to do is try to code this up in real time so you can experience the looking at documentation and struggles in real time with me. All right, so I'm going to use my draw circles function. Basically, here's my strategy. I'm going to initialize an empty plot, and then I want to put the numbers on, and then I'm going to draw some arrows. I think I can use the arrows function, but we're going to have to look at the documentation and maybe do some decorations. So what I like to do when I'm working on code is just to write the comments in first. Now these may change. Maybe the model I have for how the code's going to work is not actually going to work in practice, but it's kind of good to get some comments down just so you can have a big picture idea of what's going to happen. So the first thing would be to initialize an empty plot, add the numbers 1 through 12, and then I'm going to draw arrows for the clock hands. And what else? Maybe we'll add some decorations. Okay, so to initialize an empty plot, that's pretty easy. I can say plot, you can really put anything here. Type equals n, and we'll say xlim equals, we're probably gonna, so I want to put the numbers around the unit circle, but we're probably gonna want a little bit of extra room. So maybe I'll say, actually what I should do is create a parameter. So plot size equals 1.5. That way I can change this if I want to. Clock should be kind of symmetric, so we'll say ylim is the same as xlim. And what else? We probably want no axes. And this is kind of ugly looking. Those should go together. Wonder if I can omit this. What happens? All right, let's try running that. Okay, actually you do need the X. So let me add that. Okay, that's fine. All right, so I want to add the numbers 1 through 12. So I could do this with the text, but I'm going to need the X and Y coordinates. So I'm going to use my circle function. And what the heck was that called? Circle points. And I need 12 of them. And I need 0 noise. I don't want them to be, I want them to be right on the unit circle, basically. So circle points. Okay, x1 and x2, so we don't have to reference circ over and over. And all right, let's give this a shot. So text x1, x2, and we'll say 1 through 12. I already know this is not going to work, but I want to do this anyway. It's not going to work quite right. All right, so there's my clock, which doesn't look very good because, first of all, clockwise is counterclockwise, and the numbers aren't in the right spot. So I can either change my function, which I think I don't want to do, or I can just reorder the numbers the way I want them. So I want 1 to be, let's see, how do I want to do this? I see. Basically, let me do this. So you see the 1 goes here, so it's going to go it should go 2, 1, then 12 back to 3. So maybe I'll do C 2, 1, 12 to 3. Let's see if that works. And I need a new plot. Oh, I didn't use nums. All right, that looks pretty good. Okay, that's a good start. All right, now we want to draw some arrows. Actually, I put this in the wrong spot, didn't I? Okay. Now I'm looking at this clock and I'm not super happy with it because you can see this is actually not in the middle of the graphics device. So probably we're going to want to come back and add some, fix the margin so that things are in the middle. Also, my graphics device is not, it's not square. It looks like it's more tall than it is wide, but we can deal with that again later. Okay, so let's try drawing some hands on the clock. I think I first want to do a point in the middle, you know, where the hands emanate from. And the way I've drawn this, the middle of the plot should be 0, 0. And I think I want it to be a filled circle. So that's that. That's 16 is the filled circle. And maybe I'll make it big, double the normal size. Okay, that's probably, well, we can always mess with this stuff. So that's probably too big. Annoying thing about this, you have to keep starting over. Okay, that's all right for now. All right, let's draw some arrows. And I honestly don't know how to use the arrows function, so let's take a look at this. All right, arrows, x0, y0, x1, y1. So x0 and y are the coordinates of the points from which to draw. So that should probably be 0, 0. But maybe not. Maybe, yeah, let's start with that. That should probably be 0, 0. X1 is coordinates of the points to which to draw. And you have to supply at least one of them. Okay, I'm not sure why. Length of the edge of the arrow head. Okay, so we'll probably mess with that. Angle from the shaft of the arrow to the edge of the arrow head. Okay, probably mess with that too. What's the default? 30 degrees. I'm assuming that's in degrees. Oh, we have multiple kinds of arrows that we can try out. That'll be fun. Colors, line types, line width. And then other things. Okay. All right, let's give this a shot. So we'll do arrows. Let's do the hour hand first, which should probably be like thicker. So x0 equals 0. So it should start at the origin. And I don't know if you know this, whenever you see a watch ad with a clock that looks like this, or a clock ad, they always have the clock set to 10:10. I'll show you why in just a second. So I'm going to try to set it to 10:10. So I got to figure out at least approximately what that point is. So x1 equals, so the x, let's try cosine. 1, 2, 3. Okay, this is going to be a guess. 2 times pi times 1, 2, 3, 5/12. Okay. And I'm probably going to mess up the cosine and the sine, but we can fix that. Okay, I'm going to try that just to see if it works. Hey, that worked. Okay, good. All right, we probably don't want it to cover up the 10. So maybe we do something like, let's see, our fac. Maybe we do that. And this is going on to 2 lines, so let me make that look a little nicer. Actually, I don't like that at all. All right, that looks better. Okay, so there's that. That's a little shorter. And of course, we got to keep starting over. That's kind of annoying. Okay, that looks good. I probably want it to be thicker. So let me do 2. That's not even thick enough. Let's do 4. Okay, that's pretty good. It's still not thick enough. All right, that looks good. Let's go with that. All right, that's the hour hand. And I think minute should be a little longer. Let's do this. And it's going to be set to 10:10. And it's going to be narrower. That's not long enough. It doesn't really look much longer. Oh, that's because that's because it's hour fac. So let's do that. All right, that probably looks better, but I've overplotted it. So I'm going to need to redraw the plot, add the numbers, add the arrows. Okay, that doesn't look so bad. I think I want to make my circle bigger, and my numbers are too small. So let's fix that. I mean my circle in the middle, this one. Let's make it really big. Let's make it like 8. Oh, that's too big. Oh, now we can't see. Okay. That's not pretty, but that'll do the trick for now, I think. All right, so let's fix some things up. I want to work on the numbers, so I think they should look nicer. They should be bigger. Let's make them twice as big. Ah, that looks a lot better. I'm just going to delete these for a second so I can keep running it. That looks a lot better. And, okay, I want to show you the Hershey font. So, question mark Hershey. All right, so there's some special fonts in R. You've probably seen bold and italics and maybe even a serif font. But there's a few kind of pretty fonts. And they're in this, I don't know why they're documented. Well, they have to be documented somewhere. So they're documented here in question mark Hershey. And there's some information about what Hershey fonts are. I think they're like open source fonts. So you can set all of the fonts in the par command, but you can also set them in the call to text by specifying an argument called vfont. Let me show you where that is. When using the text and contour functions, Hershey fonts may be selected via the vfont argument, which is a character vector of length 2. See details. This allows Cyrillic to be selected, which is not available via the font families. Okay. So vfont specification. Hershey font is specified via typeface, e.g. serif or sans serif, and a font index or style, e.g. plain or italic. First element specifies the typeface, second element specifies the font index. There's something called demo Hershey if you want to look at it, but that's honestly kind of hard to look at. Okay, so here are the list of things you could do. So the first column is the first entry of this vfont vector. So there's these different serif fonts. Serif means it has like little decoration on the end. Sans serif means like the default here, this is a sans serif font. There's script fonts, and then there's these Gothic ones. We'll check those out. So let's try this. So get out of here. So vfont equals and I kind of want to have this documentation open, so let me do this. Okay, now we can see it at least. Okay, so we have, let's try serif. Is plain an option? Probably. Serif plain. Oh, that's a lot nicer. Okay. Maybe bold would look even better. Ooh, beautiful. Let's try these Gothic ones though. What is it? Gothic English? Yeah. And can we do bold? No, we can't do bold, so we have to say plain. Oh, covered it up. I don't know. I don't like that. Gothic German? Now, is that the same? That looks pretty similar to the serif one. Yeah, I think it's exactly the same. All right, maybe we're stuck with that one. That one's pretty nice, though. Let me try Gothic Italian. Oh, bold doesn't work. That's the same. Okay. So I think I'm limited in my Hershey fonts on this system. So let's just keep it simple and say serif bold. Okay, that's looking pretty good. And we have our arrows. What else? Oh, I promised to look at the arrow types. So there's a code. What does the code do? Integer code. All right, let's try these out. Code equals 1. Of course, we can't see that. All right, I'm gonna, just to make my life easier, I'm gonna get rid of all the, we'll put these back in. All right, that's not what we want. 2, I think was the default. Yep. Let's try 3. 3. Oh, that's a two-way arrow. That's a no arrow. Maybe there's only 3 types. Okay, I think there's only 3 types. All right, so we're stuck with 2. That didn't really give us anything interesting. What else can we do? LTY. We could change the color if we wanted. What does LTY do? Oh yeah, we want to do L end. So I think we might be able to get different end types. So let's look at this. XPD, L end, L join. Scrolling. LN, line end style. 0 for round, that's the default. Okay, that makes sense because we have round arrows, ends there. 1 and but mean but line caps. 2 and square. All right, so we can do 0, 1, or 2. We'll try those out. L join is the same. Well, bevel. Okay, I don't even know what that means, so we'll just try those out. So L end and L join can be 0 through 2. L miter. Okay, I'm going to skip that because I don't know what that means. Maybe you can try that. Line type, so there's solid, dash, dotted, dot, dash, 2 dash. I don't think we want any of those. Line width. And there's something called X. Is that what it's called? What is XPD? XPD. Logical value or NA. If false, all plotting is clipped to the plot region. Oh, no, we don't care about that. That's if you want to have things extend beyond the plotting region. I think we don't care about that for this particular exercise. Okay, so we'll leave that. And let's play with the, let's do it on this one. L end equals 0. That didn't change anything. Was that an error? No. Oh, that was the default, so that's why. Oh, okay. That's not bad. Maybe I like that better. Let's try number 2. Oh, that's ugly. But maybe we need to change the L join. L join. Also ugly. See, I don't like how the point of the arrow looks silly. I want it to be a point. Maybe this will do it. That's better. There's still something sticking out at the end, though. Maybe I need to do... All right, let me try a 2 just so we cover our bases. That looks terrible. Let's try 1 and 1. Ah, that's what I want. That looks much better. I'm going to stick with that. Okay. Let's also change... we don't need the code, right? That was the default. Let's add this to the other one. Oh, beautiful. Okay. All right, let me show you why it's set to 1010. So I'm going to add a logo or a company name. What should we name our watch company? Oh, that's a good question. Text. All right, so I want to add text. I want to put it right in the middle. Usually that goes like right here. So we'll say the X value is 0. The Y value, I'm just going to guess 0.5. And our watch company is called, I don't know. I don't have a good name. I'll call it Watch Co. Okay, that's not bad. I want to put it in one of these pretty fonts though. B font equals and let's make that bigger. Too big. Slightly too big. Let's go with that. Okay, that looks good. What else? Okay, so why is it 10:10? So when you read a clock, if any of you actually know how to read a clock, if you still learn that in school these days, obviously you have to look at the hour hand. So it looks here, and then you have to move your eyes over to the minute hand, which is here. So if the clock is set to 10:10, your eyes are forced to move over the company name. So if in the ad it's set to 10:10, you're kind of forced to look at the company name if you want to read the time, which you kind of do instinctively when seeing a watch face. So that's why if you see a watch advertisement, it's always set to 10:10. You can check me on that. All right, so that looks pretty good. What else do we want to fix? Let's open our plotting device and make it square. Can we do that? So we have to do that up here. So we'll do X11. And we'll say width equals 7. But this is already square. Oh, that's exactly the same. Maybe it is square. I don't think it's square though. All right, well, forget about that. What I do want to do is change the margins. So I'm going to do mar equals, I'm going to set them all to 0 and see how that looks. Ah, that's much better. Okay, there's my clock. What else do we need? Oh, I think it'd be nice to make it a square clock. I guess you could make it a round clock. But I'm going to try a square clock. And so to do that, I'm going to add a frame, like a rectangular square frame. So I want to use the rect function, but I forget how to use it. So, all right, X left, Y bottom, X right, Y top. Okay, so you have to give the 4 coordinates of the rectangle. You have to give it a density. I don't know what that means. Oh, that's probably if you should fill it in or not. Angle. I don't know what that does. Density of the shading lines. No shading line. I don't think I want shading lines. Angle the shading lines. I don't know what that is. Oh, I think I know what that is. We'll look at that just so we can see, but I think I don't want that for this plot. You can fill the rectangle. I don't think I want to do that. Border. All right, we'll take a look at the border maybe. Okay, so let's try. So I want to say how big to make it. So I'm not good with names. So rect size equals 1.5 Let's try 1.2. So rect. So what do we got to do? Minus 1.2. Oh, rect size. Minus rect size. Okay, that's not bad. That's not terrible. Let's try this. Okay, now I forget the arguments. What did we want to look at? Come on. No documentation for rect? What? We just used it. There it is. All right. Density, angle, border. All right, let's try this. Density equals 1. Oh, that's what it does. Okay. Yeah, we don't want to do that, but that's what density does. Oh, maybe we have to have density. Okay, that changes the angle of those lines. We don't want that either. Although maybe you do. I don't know. I don't want that for my clock. And let's try border. That did nothing. Maybe we have to make it really big. No. That changed the color. What the heck does border do? All right. Border equals null. Oh, that's just the color. I didn't read that carefully. Okay. I guess we could have a red clock. Why not? Okay, we'll have a red clock. Now, how do we want to do this? There's probably a way. I'm just going to run this again. Oh, that doesn't look good. That doesn't look good at all. I thought that would look better. Maybe we should do it. Thicker? Thicker's a little better. Let's try 4. Okay, that's not terrible, but I think they're too far apart. The two lines are kind of distracting. I think I would really want it to be a solid border. There's probably a way to do that, but off the top of my head, I don't know. I'm going to make this 1.3. That looks a little bit better. Maybe I'll make it, you know, probably the hack to do is just to make a single one and make it really thick. So get rid of this and do like line width of 10. Oh. Oh, that actually looks pretty smart. That's not bad. Let me push it out just a little bit and make it a little thicker. Oh, that's a pretty good looking clock. What else do we need? Maybe we'd want to add like some tick marks. Some clocks don't have tick marks. What else? Are the numbers big enough? Let's make the numbers a little bigger. Where was that? Text. Oh, that's much better actually. Let's push it. Let's push it to 3. Oh, now we're looking good. Okay. All right, I'm satisfied with that clock. What do you think? Okay, as a fun exercise, what you could try doing is write a function that takes in, so create your own clock, don't copy mine, but write a function that takes in a time, or minutes and hours, and draws a clock with it set to that time. And actually, this is not 100% accurate, is it? Because if the minutes are set to 10, the hour hand should not be pointed directly at 10. So maybe that's something you could fix on your plot. You know what I mean? This should be not exactly at 10. This should be basically 1/6 of the way to 11, because this has gone around 1/6 of the way. Okay, so you can fix that in your plot, but for now I'm happy with this clock. Okay, that's it for graphics. There's a lot more to learn. I recommend reading the documentation and thinking of projects for yourself like this one to just try. And maybe you can try this one yourself. It's a lifelong learning process. Okay, see you next time.